This next project's going to be a rustic birdhouse, an outdoor birdhouse, not a Christmas tree ornament birdhouse. When I put this one on my list, I couldn't help but think back about 55 years ago as a youngster in my granddad's shop. I remember my first attempt at maybe creating something out of wood, and that was pounding nails into these little pine boards to create a birdhouse with my granddad's assistance. I think it's kind of funny. 55 years later, here I am creating a DVD that includes how to make a birdhouse. But that's what it is. Hope you enjoy this one. I went to my local lumber store, purchased a couple of these cedar fence boards. They measure about 11 plus inches wide. The first step will be to build a cylinder about 8 inches in diameter out of 16 vertical staves. I'll take that 8-inch diameter, multiply times pi. That'll give me a circumference a little over 25 inches. Divide that by the 16 staves. Gives me my approximate stave width. And for the angle, it's a simple matter of just taking twice the number of staves, 2 angles each, and dividing into 360 to give me my 11.25 degree miter angle. So to get started, I'm going to cross-cut some material a little over 7 inches long. I'll take these boards over to my table saw and make one more pass to get exact parallel surfaces. Then using the same sled that you've seen me use before, make an end cut here. The stop block has been adjusted a little more than 1.5 inches away. My hold down device has foam and it straddles the cut line. Secures both pieces of wood. Now I'm at the chop saw chopping up little pieces from those first cut staves. I can take 16 of these, do a dry fit to confirm my angle, and I can check my diameter. I came out a little less than 8 inches, but there's nothing exact about this project. I really don't care if it comes out at 7 inches. With that 11.25 degree angle confirmed, it's a pretty simple matter now to cut 16 staves. Line them up in a nice straight row, secure them with a couple of strips of duct tape, roll this into a cylinder, and secure it first with the extra length of tape and then with a couple of hose clamps. I can do an inspection just to make sure I've got the fit that I want. Now it's a matter of gluing it together. I'm going to use Titebond 3, which is a waterproof glue. Also gives me a little more working time. Spreading glue everywhere. You have to work fast still, even though it's Titebond 3, which gives you more time. I'm securing this now with 5 hose clamps. That'll give me plenty of pressure spread out from top to bottom. You do have to pay particular attention to the inside of the cylinder. Make sure stave doesn't slip inward. Now I'm going to the next step. I've moved my stop block in about 1/8 of an inch, cutting a few more staves, narrower staves. My goal here is to create a couple more rings, smaller diameter rings, that will fit inside the cylinder. One will be used as a keeper ring to hold the base in place. The other will go in the top of the cylinder just to add strength. The diameter came out right, so now it's just a matter of gluing these together so I can use them at a later time in the project. Now it's time to work on the roof structure. If you're familiar with my ribbon construction, what I'm going to do here is build 3 angled rings using compound miters. To do those angled rings, I need to know the miter angle and the blade angle. So I've gone to a chart. This one happens to be in the back of my book. But I'm on the column for 16 staves, on the row for 45 degrees of slope angle. It lists both the miter and the blade angles. Here are the 2 magical numbers that I need. But on a chop saw, and most saws, that angle is measured from the blade, and we have to measure from the fence. So it's a matter of just subtracting from 90 to get that miter angle, and then there's the blade angle. So over to my chop saw, I've put my blade angle just a smidgen under 8 degrees, and I've put my miter angle right about 8 degrees. Here are the boards that I'll cut. These are cross-cut pieces of cedar at 3¼ inches. And I've ripped some thin pieces of redwood. I'll cross-cut these into short pieces and put them in between the cedar. Now, I also need to know how wide to cut my staves. So back to the same formula. Diameter times pi to give me circumference, divided by, in this case, 16. And I have to subtract the 0.13 for the redwood, so I'm going to cut these pieces about 1.6 inches long. I'm not going to spend too much time on this because it's thoroughly covered in my Volume 3 DVD, but real quickly, I've set a stop block at the proper distance. I've made a cut. I can cut and flip and cut and flip. Now I've got 8 compound mitered staves taped together in order to test the angles. In this case, this is certainly close enough to proceed. I'm also checking the diameter, and I'm well within the range there. So now it's just a matter of gluing up 8 pairs. I've put the piece of redwood in between there, and I'm using an assortment of rubber bands. Some are doubled, some are tripled, in order to get the consistent pressure across the seam. Here are the 8 pairs that'll make up my first ring. Now I can take those 8 pairs, prepare those to go into quarter sections. The duct tape trick to hold the seam together tightly on the outside works very well in clamping situations like this. Rubber bands provide the pressure for the inside. Here's my 4 quarters, and there's the 8 pairs for the next ring. Now to mount the cylinder, I've turned an internal jam on this piece of MDF, secured it with a tailstock, put a solid bead of hot melt around this edge. This is not going to have any aggressive turning. The hot melt should hold it fine. Now I'm back to my first roof ring. I've taken those 4 quarters and taped them together into halves in order to confirm that I'm in the ballpark on my overall fit. If they did not have a good fit, I would have touched them up on the disc sander to get these quarters to form perfect halves. Here I'm using the duct tape trick to put the quarters into halves. This is actually Gorilla Tape, but duct tape works better. It has more elasticity. I'd just run out. Getting a perfect fit on the 2 halves almost always requires a little touch-up on the disc sander. I'm using the pencil line trick once more here. Those pencil lines disappear real quick. I know I've got flat surfaces in all 4 corners. The final clamp job here is pretty interesting, but not difficult. It's just a matter of getting creative with rubber bands, applying them in several different directions. Do it dry a couple times, and you'll find that you can provide plenty of pressure with those rubber bands in a situation like this. Difficult clamping challenge solved easily by rubber bands. Next, I want to put the keeper ring in the base of the cylinder. So I've attached it with a couple of beads of hot melt, trued it up, put a slight taper on this outside, remove it from the MDF, and then go to work on the bottom of the cylinder. Just a little turning, some trial and error back and forth, getting these 2 tapers to match. It takes a little time to do this. Plenty of glue. Notice the hose clamp, that's providing some extra strength on the cylinder while I tap this into place. Notice the pencil marks, so I have a bricklay effect on the way this keeper ring goes into place. Now I can true up the bottom of the cylinder. I'm making this base flat so it can be mounted on another piece of MDF. Next I'll take the top off this piece of MDF. It should come right off because there's no glue on the internal surfaces here. Now turn a new piece of MDF to perfectly match that base diameter. Bunch of glue, smear it around. I'll also add a little weight in the form of an 8-inch faceplate. Now I can go to work on the first roof ring. Using the large cone on my tailstock, that centers it. Just a few hot melt beads, every 2-3 inches holds it on there. getting a nice clean surface on this end so I can fit up a piece of MDF. This has been turned at about a 45-degree angle. A little tight on the inside, a little more removal here gets this to fit. Plenty of glue and some tailstock pressure holds this in place while the glue dries. Once the glue is set up, I'll retrue or return this tenon, and I'll also turn a little opening there that'll come in handy later on. Removing this just requires a little parting tool cut. It should come right off. Now I'm back to the cylinder, putting this other internal ring in the top of the cylinder. But before I did that, I slipped in this solid piece of cedar that'll act as the base of the birdhouse. It'll be trapped between the top and bottom internal rings. To start the process of installing the roof rings, I'm turning about a 45-degree angle there at the top of my cylinder. Here are my 3 roof rings ready to be installed. The first one, I'm just cleaning it up, getting smooth surfaces everywhere, consistent wall thickness. Then I'm going to do something a little different. I'm going to hit it with a wire wheel, a wire brush wheel, just to emphasize the grain and create some texture. And next I'm burning it. This will also give it a more rustic look, which is what I'm looking for. After burning, I'll take a wire brush, get rid of all the loose carbon, back to the cylinder, a hole for the bird, and then I'll wire brush and burn this surface as well. Then taking a wire brush again to get rid of the carbon. A dry fit on the top here reveals just a little teeny gap, so a little more turning here on the slope to get a better fit, plenty of glue, and that hole that I turned in the MDF earlier, that certainly comes in handy to get this thing accurately mounted. To get the next 2 rings installed, it's very much the same procedure. Here I'm just getting rid of the MDF that's at the top of ring 1, cleaning up this opening, and getting ready for ring number 2. Here it is, all turned, smooth surfaces, a good fit. The same process of burning it and wire brushing it ahead of time. Then using the tailstock, positioning it. But here I want to protect that surface from glue squeeze out, so I've put tape and run a knife around there to get a nice clean edge. That'll save me some trouble down the road if the glue gets where it shouldn't go. Glue on both surfaces. The tailstock again holds it in place. And here, number 3 is done the same exact way. Now I'm getting rid of that top plug at the top of the roof, shaping this opening, which will accommodate a plug turned from this piece of laminated redwood. I've drilled a hole all the way down through, which allows me to secure it with a screw chuck, and later on that hole will accommodate a rope. So I'm shaping this big plug into the top of the roof, just doing the same tapered plug fit. A little more turning on the inside there to get this to seat properly. Another glue job, using the tailstock once more, keeps everything nice and true. Once that's cured, I can come back, shape this piece of redwood to conform to the rest of the roof, hit it with the torch, get it nice and crispy, then clean up the carbon with the wire brush. We're almost done. The tailstock secured it while I was parting most of it off. Break it off. I got a little mess on this edge, which I can clean up with a sharp utility blade, and torch the bottom side to match everything else. Here's the underside. Doesn't look too bad. Now the rope installation is real simple because I've got that floating base. I can reach up there, grab the rope, tie a knot, and melt that knot with my torch so it can't come untied, and that just pulls right back up inside. There's the floating base again that's now back in place. The one last step is to draw a hole that'll accept a piece of branch wood, just in case some local bird might want to call this place home. I have a little confession about the lumber I used for the birdhouses. The cedar boards that I used, I literally had to dig out from under 2 feet of snow at the local lumber store to get them. And I didn't give them nearly enough time to dry out. With hindsight, I should have had those air drying inside a warm environment for probably several months at least. The birdhouse has been together for a couple of months, and it shows no signs of falling apart. Having, consistent wood grain alignment helps a lot, but with hindsight, I really should have dried that wood a lot more than it was. So just remember that if you're going to do this project, get your cedar fence board well ahead of time and get it a little drier than I did. One other thing I came to realize on this project, the hole for the bird, the opening, probably should have been drilled a little higher from the floor, just to provide more room for any nest building.